Assalamu alaikum and hi everybody. It's great connecting with you again. Okay, now, we will continue our online class on EBT419 Applied Metallurgy. Today we will discuss about another sand-based molding methods under the expandable mold in metal casting process. Look at the chart here. In expendable mold casting, vacuum mold casting is fall under no bond process. Vacuum mold casting, also known in manufacturing industry as the V process. It employs a sand mold that contains no moisture or binders. The internal cavity of the mold holds the shape of the casting due to forces exerted by the pressure of a vacuum. Vacuum molding is a casting process that was developed in Japan around 1970. The vacuum process or V process is truly a crossover process as it competes at different levels with all the other casting processes. V process casting is a very efficient way to produce both development and low to moderate castings. Vacuum molding or V process is a variation of the sand casting process for most ferrous and non-ferrous metals, in which unbonded sand is held in the flask with a vacuum. The vacuum here serves as the sand binder. The pattern is specially vented so that a vacuum can be pulled through it. A heat-softened thin sheet of plastic film is draped over the pattern and a vacuum is drawn. A special vacuum-forming flask is placed over the plastic pattern and is filled with a free-flowing sand. The sand is vibrated to compact the sand and a sprue and pouring cup are formed in the cope. Another sheet of plastic is placed over the top of the sand in the flask and a vacuum is drawn through the special flask. This procedure will hardens and strengthens the unbonded sand. So, the compacted sand gives the sand its necessary strength and hardness. The vacuum is then released on the pattern and the cope is removed. The drag is made in the same way or without the sprue and pouring cup. Any cores are set in place and the mold is closed. The molten metal is poured while the cope and drag are still under a vacuum, because the plastic vaporizes but the vacuum keeps the shape of the sand while the metal solidifies. When the metal has solidified, the vacuum is turned off and the sand runs out freely, releasing the casting. One significant technology that sand-based casting has embraced is V process. Look at the figure 1 here. The basic of V process consists of injecting molten metal under high pressure into a steel mold called a die. With a vacuum-assisted system, a vacuum is drawn in both the shot sleeve and the mold cavity before the injection shot occurs. Almost all air is positively evacuated from the mold and the vacuum is maintained until the injection cycle is completed. Vacuum-assisted in V process casting decisively reduces gas porosity in the casting. This significant reduction in the volume of gas porosity and the pore sizes in castings has the result of markedly improving the density and tensile strength of the end product. A good vacuum in the mold cavity enables the alloy to flow into blind recesses in complex shapes. It also allows the fronts of the molten metal to merge freely without forming Schutz failure. V process procedures. According to the schematic diagram here, there are 9 steps in the V process. Step 1. The pattern with vent holes is placed on a hollow carrier plate. Step 2. A heater softens the .003 to .008 plastic film. Plastic has good elasticity and a high deformation ratio. Step 3. Softened film drapes over the pattern with 200 to 400 mm Hg vacuum acting through the pattern vents to draw it tightly around the pattern. Step 4. The flask is placed on the film-coated pattern. Flask walls are also a vacuum chamber with the outlet shown at right. Step 5. The flask is filled with dry, unbonded sand. A slight vibration compacts sand to maximum bulk density. Step 6. A sprue cup is formed and the mold surface leveled. The back of the mold is covered with unheated plastic film. Step 7. Vacuum is applied to the flask. Atmospheric pressure then hardens the sand. The vacuum is released, pressurized air is introduced into the carrier and the mold is stripped. Step 8, the cope and drag assembly forms a plastic-lined cavity. During pouring, molds are kept under vacuum. Step 9, after cooling, the vacuum is released and free-flowing sand drops away, leaving a clean casting with no sand lumps. The sand is cooled for reuse.
Let's take a look.
Design of V process. All materials that can be cast into sand molds. Any metal including gray, ductile, malleable iron, various grades of steel or aluminum and copper base alloys may be poured in a V process mold, with the possible exception of magnesium. In term of design, V process provide better accuracy than bonded sand molds, since compaction is more uniform, and the mold is comparatively rigid. Casting defects associated with bonded sand molds such as gas and expansion defects, and hot tears are minimized. Deep forms, and sharp corners and edges, should be avoided to minimize the risk of wrinkling and tearing of the plastic film. Surface finish depends on the grain size of the sand, which should be fine, to avoid metal penetration under vacuum, and is better than bonded sand molds, being typically in the range 6.3 to 12.5 micrometer radius. Other design features are similar to conventional bonded sand molds as conventional sand casting. There are several advantages of V process. First, it gives good dimensional accuracy and surface finish with generally twice the accuracy of sand castings. The absence of moisture-related defects, especially gas hole defects. Pattern life is longer because there is no contact between the sand and the pattern. Is suitable for a wide range of casting sizes from grams to tons. Sand is completely reusable. The process can be used for complex geometries and can be automated to achieve greater consistency and productivity. No fumes generated during the pouring operation, so, V process is one of the green technology in the casting. Exceptional shakeout characteristics. Eliminates the use of binders and minimizes sand waste. It can be highly cost competitive with other casting processes because, one of the reason is binder cost is eliminated and sand can be recycled. It is seen that the V process has many interesting advantages, but the fact is that each of process casting are actually complements each other. Here are some disadvantages about V process. First, V process requires plated pattern equipment, so this process used primarily for production of prototypes. It is actually relatively slow process. It is low to medium volume parts, so it typically not suitable for high rates of production. Close synchronization of mold and metal readiness is essential in foundry practice. is not suitable for some casting geometries due to flexibility limitations of the plastic. That's all for now. We will continue the online lecture on another expendable mold casting on the next slide. Thank you for your attention. If you require any further information or question regarding this topic, please do not hesitate to contact me through our group WhatsApp, Telegram, or even you can call me personally. Assalamu alaikum. See you then. Bye.